Hello everyone, my name is Abhinav, and as a part of Coursera Machine Learning Foundation for Project Managers, I am giving this presentation. The topic for my presentation is predicting electrical energy output of a combined cyclic power plant using a machine learning approach. So first of all, I would like to give you the project overview. So the objective of our project is to build a model to predict the electrical energy output PE of a combined cycle power plant. So, and the data which is given to us is having a number of 9,568 hourly average ambient environment readings. The variables that is present in the data is if I can divide them into two different sections like independent variables and dependent variables. So the independent variables are those which we are using for our prediction and for doing the prediction of dependent variable. So the independent variables which are present in the data is the temperature, ambient pressure, relative humidity, exhaust vacuum, and the prediction which we have to do is to get the net energy output. So the machine learning approach that I'm going to follow is like for modeling tool I'm using Python and Java, Jupyter Notebook, and the type of ML approach that we are going to follow is regression since we are predicting a continuous variable. And the output matrix will be that I'm going to use is R2 MAE, mean absolute error, and mean square error, that is MSE. So the potential features that we are going to use is temperature, ambient pressure, relative humidity, and exhaust vacuum. And the target variable, as we know that this we are going to get the prediction of PE. Okay, so first of all, I have done some data description to get the descriptive statistics for the data that we have loaded. So as we can see that we are getting the different stats for different variables. So the count is coming as 9,568 for each and every variable. So it shows that these are the not null values. So as we can predict that there is no null value, so we do not have to treat any missing values over here. And we are getting other stats as well, like mean and the standard deviation, the minimum value, and different quartiles and the maximum value of that particular variables. So after that I have done the data distribution for all the different variables. So as we can see, like apart from exhaust vacuum, mostly the data is like fairly distributed, while the relative humidity is like right is skewed, and other than that we can see that okay, data is fairly distributed among the entire plot. So after that I have calculated the correlation coefficient for uh, for all the variables which are present in the data. So after that I can come to the conclusion that temperature is very strongly negative correlation related with the PE value, which is indicating like higher temperature leads to lower electrical output. And same is for the exhaust vacuum. So that one is also strong negatively correlated for with the PE value, while the ambient pressure is moderate positive correlation it is showing, which is suggesting like higher ambient pressure increase the electrical output, while the relative humidity is very it's kind of a weak positive correlation with the P, which is indicating a slight increase in electrical output with the energy with higher humidity. So the overall I can come to the conclusion like temperature and exhaust vacuum significantly impact electrical output, while ambient pressure has a moderate effect and humidity has a minor influence. So now I'll come to the data split and model selection. So I'm using a test split of 80-20, and the validation strategy that I'm following is the fixed validation sets. And the algorithm that I've considered for this problem is decision tree regressor, linear regression, polynomial regression, and the random forest regressor. And after successfully executing the entire Python script, this is what the model comparison with the different scores I'm getting. So for the decision tree regressor, as you can see, the R2 score, MAE score, MSE score are coming. Same for linear regression, polynomial regression, and the random forest. So all the matrix and the numbers are coming in this matrix. And with this matrix I can come to the conclusion like the random forest regressor is the best model for predicting the electrical energy output, since it is the highest R2 value and the lowest MAE and MSE values. So it provides the most accurate prediction and the most reliable in capturing the relationship between the data. So this is coming as a winning model for me, and I can conclude with that like random forest regressor is the best suited model for my use case. Other than that, polynomial regression, linear regression, and decision tree regression is like least performing, like not the least performing. I can say like these are not better than the random forest, so they are way behind random forest regressor. So that's why I'm not considering them for our prediction. So yeah, that's it from my side. Thank you.